Hello students, welcome to my channel Vision Unlimited. In my last video, I have discussed with you what are the different types of real numbers. Real numbers includes both set of rationals as well as irrationals. Rational number includes set of integers also. So in this video, I will be teaching you what is Euclid's division lemma. Now before coming to Euclid's division lemma, let us study what is divisibility of integers. Before coming to definition of Euclid's division lemma, let us first understand what is the divisibility of integers. Now, we all know what are integers. Let me consider a simple example of an integer 12. Now, if we factorize 12, it can be written as 3 into 4. It can be written as 3 into 4 as I factorized 12. So, I can say that 3 divides 12. From here, I can say that 3 divides 12. As 3 and 4 both are factors of 12 and every number is divisible by its factor. So I can say 3 divides 12. Another way to write 12 is 12 is equal to 6 into 2. Again I can say that 12 is written in terms of its factors 6 and 2. So from here again I can conclude that 2 divides 12. Now, why 3 divides 12 and why 2 divides 12? 3 divides 12 only because of the existence of 4. 3 divides 12 only because of the existence of 4. Again here, 2 divides 12 only because of existence of 6. And notice one thing, 12 is written in terms of its factors and both the factors are integers. Both the factors are integers. Here again 3 and 4 both are integers. 3 divides 12 only because there exists an integer 3 such that 12 can be written in terms of 3 into 4. Again, 12 is divisible by 2 only because of existence of the integer 6. If I write why I am stressing on the word integer, why I am stressing here that only because of existence of integer 6, 2 divides 12. Let me clarify this thing. So if I write 12 is equal to 2 into, let me take another example. If I write it 12 as 7 into, or let us take it as, just a minute. If I write 12 as 14 into 6 over 7. Now here I cannot say that 14 divides 12. If I write here 14 divides 12, then I am wrong. Why I am wrong in saying that 14 divides 12, or if I say that 12 is divisible by 14, why I am wrong here? Because there does not exist any integer such that 12 can be written as 14 into that integer. Here it is divisible by 2 because there exists an integer such that 12 is equal to 6 into 2. The same condition holds for negative numbers also. Let us take another example. Say if I am writing minus 36 as 9 into minus 4. Now I can say that 9 divides minus 36. Why? Because of existence of integer minus 4. 9 divides minus 36. Why? Because there exists an integer minus 4. Now, our question was, our thing was, what we have started with? Divisibility. Now, what is divisibility? Let me clarify you the definition of divisibility, which will be used to define Euclid's division lemma. Now, look here. If there exist two integers, say if there exist two integers, say a and b. If there exist a and b are two integers, and if there exist another integer c such that a and b are the two integers, then if there exists another integer c such that a is equal to bc, then I can say that, what I can conclude from here, that b divides a. And in mathematics, this thing is written as b, just a minute, this thing can be written as b divides a. This symbol stands for b divides a. Now, if I write 6 divides 28, now is it true or false? If I'm saying 6 divides 28, here this symbol stands for this line, straight vertical line stands for divides. B divides A. So here I have written 6 divides 28. Now my question is, it is true or false? It is true only if I can write 28 as 6 into something. But here I cannot write 28 is equal to 6 into something. I cannot write. I can write it as 7. मेरे पास में I cannot write it directly 6 into, with what fraction should I multiply to get 28? If I multiply it with 7 over 3, I will get 28. No, I won't get. I have to multiply here with 14. 3 into 2, 6, and 2 into 14 is 28. But there does not exist any integer so that I can write 28 is equal to 6 into that integer. That's why this 28, 6 does not divide 28. That's why I can say that 6 does not divide 28. So it is clear that what is divisibility? If b divides a, then there exists an integer c such that a is equal to bc. Now let us discuss another important fact here. What will happen if you get the result a divides b and b divides a? It is possible only if a is equal to b. This thing is possible only if a is equal to b. Say if a is equal to b is equal to 5, then I'm having 5 divides 5 and 5 divides 5. But if question is coming into your mind, if they are different, then is this thing possible? Let us discuss that also. If I'm taking a divides b, say 5 divides 10, then 10 cannot divide 5. If 5 divides 10, then 10 is a multiple of 5. 10 does not divide 5. It means this thing is false. So if A divides B and B divides A, then the result is A is equal to B. Now let us come to the actual topic, that was Euclid division lemma. Now before coming to Euclid division lemma, let us take another set of numbers 58 and 9. So if I'm dividing 58 by 9, you all know how to divide this. How I will divide 58 by 9? It is very clear that 58 is not exactly divisible by 9. If 58 is not exactly divisible by 9, what I will think of? I will think of the greatest multiple of 9, which is just less than 58. So 9 6s are 54. If I try with this 9 7, 9 sevens are 63, which will be more than 58. So I have to start with 9 6 are 54. What will the remainder? 8 minus 4 is 4. Now I have chosen this 54 by thinking that it is the greatest multiple of 9, which is just less than 58. Such that this 4 is always less than the divisor. 4 remainder is always less than the divisor. By keeping this thing in mind, I have chosen 9 6 is 54. Done. If I have chosen, instead of choosing this, if I have chosen it like this, 9, say if I have chosen 9 5s are 45, then what will happen? 58. Then what will be the remainder? 8 minus 5, 3, 1, 3. 13 is greater than 9. That's why I have not multiplied 9 with 5 and written 45 here. And I have written, what I have done? I have written 9 6 are 54 and I have taken 4 as remainder. Now what I want to explain you from here, if I am dividing 58 by 9, if I am dividing 58 by 9, then there exists unique integers 6 and 4 such that I can write 58 as 9 into 6 plus 4. This is nothing else. This is the divisibility test which you was doing to check your division in your lower classes. So 58 can be written as 9 into 6 plus 4. Let us take some other number. If I want to divide 25 by 7. Now 7 4s are 28. So less than that is 7 3s are 21. What remainder I will get? 4. Now again I can write 25 as 7 into 3 plus 4. Now make this thing sure that remainder is always less than the divisor. Here again remainder is less than the divisor. Now this is what is your Euclid division lemma. What I have concluded from here, that if I am dividing 58 by 9, then there exists unique integers 6 and 4. Such that 58 is equal to 9 into 6 plus 4. Now, firstly thing comes into my mind that what is a lemma. Now, let me explain you what is lemma first. Lemma is nothing else. It is just lemma क्या होता है? Lemma is a proven statement which is used to prove bigger results. It's a proven statement used to prove bigger results. Now, who was Euclid? Euclid was a famous Greek mathematician who has given so many contributions in the field of geometry. And in the field of algebra also he has given so many contributions, and one of his contribution in this field was given by Euclid's division lemma. Now what is the Euclid's division lemma? Let us discuss it in detail. What is the Euclid division lemma? Now Euclid division lemma states that if there are two integers b and a, there are two integers b and a, then there exists unique integers. In case if the number is divisible, then there exists only one integer, but if the number is not divisible, that is the case of Euclid division lemma, then there exist two unique integers c and d, such that b is equal to ac plus d. B is equal to AC plus D. Now, as we are dividing, as I have divided this 58 by 9. Now, this thing was clear in your mind from the junior classes only, that special name given to this 6 is quotient. So that's why I'm going to denote it by Q, and this is remainder. So it will be denoted by R. Now let us change this. There exist unique integers. Instead of taking C and D, let me take it as Q and R. If there exist two integers Q and R such that B is equal to AQ plus R. And what is the special condition on R here? That 0 is, ये 0 से छोटा नहीं हो सकता है. Remainder cannot be less than 0 if you are dividing here. So it should be greater than or equal to 0. So it means its value can be 0. And if the value is 0, so it means it is divisible. 0 is less than equal to R and it should be less than B. So this is the statement of Euclid division lemma, which you will be using further to find HCF. From Euclid division lemma, if we repeat it again and again, we will get Euclid division algorithm, which you will be using to find HCF. Thank you. In our next video, we'll solve some problems based on Euclid division lemma.